Hello. I'm going to make a quick how-to on how to get the outer rim of this. In other words, how to figure out what the values of these points are. It all comes down to right triangles, and this is going to be messy if you're taking notes on this. There's just no way around it. But here we go. If I extend this straight down, okay, and I make a right triangle out of this, like so, we call that a right angle right there. And this would be 30 degrees. So this is a 30-degree angle. And remember, this is a unit circle. I've been asking people all day, what does that mean? It means that the radius equals 1. In other words, the radius, what we're trying to do here is find the coordinates of this point. The radius equals 1 right here. That's 1. Not down here. The hypotenuse is 1. On all these triangles, the hypotenuse will be 1. Now, a lot of people don't know, so you're about to learn this, that the side opposite a 30-degree angle is a special property. The side opposite a 30, or this side, is half as long as the hypotenuse is. In other words, if I had some right triangle like that, and that was 10, and this was my 30-degree angle, that would be 5 units long. That's how that works. So if this is 1, half of 1 is 1/2. Half of 1 is 1/2. And the question is, how long is this side? Okay? Because the XY value of that point right there is made up of these two sides, just like any point. So I want to find out how big this is, how big that side is right there. And we'll call that A. So a squared plus b squared equals c squared. So we'll have a squared plus 1/2 squared equals 1 squared. And we're just gonna do this right through here. So a squared plus 1/2 times 1/2 is 1/4. Okay, right here's that. 1/2 times 1/2 is 1/4. So 1/4 equals 1 squared, which is 1. And then we subtract 1/4. A squared equals 1 minus 1/4. What is that? 3/4. Good. Okay, 3/4. And then we square root everything. And that would be radical 3 over radical 4 when you square root a radical like that, a whole fraction. Now look at it. Radical 3 is radical 3. That's the worst 3 ever. Radical 3. But the square root of 4 is, of course, 2, and we can just leave it like that. Okay, so if you look at the answers I gave you of what the coordinates of these points are right here, that was one of them. So this is radical 3 over 2. Radical 3 over 2. So what we put in the coordinate blanks here is this x value, and this would be the up and down, or the y value. So inside this, I need to use a little bit more precise writing tool. Just, I don't know, maybe that. So it will be radical 3 over 2 and 1/2. There we go. It's a little bit better. Okay, radical 3 over 2 and 1/2. Nice. So that's that one. Now, since I can do these on different layers, we're going to go up now to the 60, because we're going to do that one next. And again, we're going to go make a triangle, straight down, straight over, and up, except I screwed that up, down like that. Red color back. Okay, this time, that angle right here is equal to 60, which means my 30-degree angle is up there. Okay, now the question is, where does the 1 go? And that's still on the hypotenuse. Right there. Okay, the hypotenuse is always 1. The side opposite the 30 is half of the hypotenuse. Let me just get this a little bit nicer picture. There we go. So the side opposite the 30 is down here this time. So that's 1/2. And the question is how big is this thing? Well, if you think about it, what we just did is that same problem. So this is going to wind up being radical 3 over 2 again. It's the same thing. 1/2 squared plus b squared equals 1 squared. That winds up being radical 3 over 2. But this time, these two things are switched positions. So I ask you, what is going to go in the x spot? 1/2 or radical 3 over 2? 1/2. Very good. 1/2. And this is the y value going up and down like that. Radical 3 over 2. All right, so there's that. Now, let's look at the 45. I'll fade that off and put the next one up there, and we'll look at this point. All right, again, making our triangle. Should always be able to do this from scratch. Just like that. Making my right angle. This time, this is 45, and guess what? That's 45 too. Hypotenuse is 1. But these two sides are, all we know is they're equal. Bless you. Preserved forever on video there just now. So one, you know, instead of calling this A and B, since they're the same, we can call that A. So what we have is A squared plus A squared equals 1 squared. And that's algebra-tastic, right? That's good stuff because I can solve for A. A squared plus A squared is 2A squared, just like x plus x is 2x, equals 1 squared is 1, and we divide by 2. So A squared equals 1/2. Square rooting, blasting through this right now. And A equals the square root of 1 over the square root of 2. Here's what that is. All right. Now I ask you, what is the square root of 1? That would be a 1. The square root of 2 is just the square root of 2. But you guys have had training on this, and you know that you're not supposed to leave it like that right there. So what we do is we multiply the top and bottom by radical 2. And that's going to be radical 2. 1 times radical 2 is radical 2. And on the bottom, the square root of 2 times the square root of 2 is 2. So if you look at the answer key, you will see that on there twice. All right, so this is radical 2 over 2 and radical 2 over 2. Now normally I would skip this, or this next part, but since, you know, there are a lot of people been out and snow days and stuff, I'm going to just go ahead and do the whole thing here. So let me fade this out, and I'll put on here, I believe this was radical 3 over 2, 1/2, radical 2 over 2, radical 2 over 2, and this would be 1/2 and radical 3 over 2. Okay? Now I want to show you what happens here. This is like a mirror image. See? This whole thing here, if I flip it over to this and fold it this way, okay, I crease the paper like that, the one that's closest to the crease is going to go here. It's like reflections in the water. So this here goes over here. Now let me get rid of all that business I just did there. So this one is going to go over here. So this is 1/2 radical 3 over 2. This would be radical 2 over 2, which is good news because you don't have to do this again. You don't have to do all the stuff we just did over and over and over, which is excellent news. But there is a difference, and that difference is signs. All right? And it's the most missed thing on the unit circle is getting your signs correct. So if you're in quadrant 2, that's of the form negative for x, positive for y. So these are all negative. In quadrant 3, they're both negative. So we got a double negative deal going on there. In quadrant 4, we have what? We have positive. Well, that turned into a 4. We have a positive and a negative going on. And then the last thing I need to tell you about this, and we'll be done, is this whole thing, if this, you can imagine that as like a piece of paper. If we fold that over this way, well then this thing would go here, and this one would go here, and this one would go all the way down here. And that's how that works. Except the signs would switch. So this one, I won't do them all, but I'll just show you. That would be radical 3/2, 1/2. And then what signs would go in there? Well, it's in quadrant 3, so it's a double negative. Now let's just do this one right here for the heck of it. This would go down in that blank. So this would be radical 3/2, 1/2. And I ask you, which one would be negative? The 1/2. Very good. And that's it, people. You can fill the rest of that in, and that's the absolute quick way of doing that. Have a good one.